This is Anvesh. Today I'm about to talk on uh, whether the SVMs can solve nonlinear problems. So, if they do, how they solve that. Before talking about this question, let's talk about how SVM solves a linear problem. So, for example, let's imagine if you have a data like this, which for now, let's consider the quarter one data. So, the way that SVM solves this problem is it draws a line. um, the main principle is the line will be drawn so that the nearest points on the both sides will have a good margin from the line. Let's imagine if you draw a line here, or if you draw line here, or line it right here. So which one will have a very good margin between the nearest points? So this is the nearest point between on the both sides. Let's say if I have the line here, the distance between from this point to here to the actual line will be having a very good margin here, which basically is try to separate those two sets with a very good margin, the maximum margin that can possibly have, so that if any kind of errors that you have on here will not by mistakenly fall onto the other category. So that's what it's trying to say. Like, it draws a line here with a maximum distance, which keeps a lot of distance from the other sides if the distance exists. Okay, so now let's talk about the how SVM solves the nonlinear problems. So for example, if we take 4 quarters of data in this example, uh, so how SVM can solve this problem? Let's introduce a third factor saying, before talking about this, can we actually solve a problem in a linearly fashion for this problem? No, we cannot draw a single line that can separate this whole thing, because we need to draw like this, something like this, which we cannot draw with a single line. So the way this is solved using by introducing a third factor. Let's imagine if you introduce this third factor z, which is equal to x square plus y square. What I'm adding here, if you see, the distance from the origin to any point is square root of x square plus y square, which you already know, uh, which means I am actually squaring the distance of my points. So for example, all these points that are close to the origin will have a less z value, right? Because they are very closer to the origin. But all these O points that are away from the origin will have a good value of z, like a very high value of z, right? So for example, if I draw these points on the z-axis value, all my x will be, as we discussed, all the x will have a less value and all the O's will have a greater value. Now we can actually draw a linear solution, linearly separable line. Like for example, if I draw a line here that divides these x and O's, now we can solve this problem in a linearly fashion. So this is called the kernel trick. So what do you mean by kernel trick? So by adding this third factor, we can actually solve a problem that is not linearly separable like this problem. By adding this third factor z, x squared plus y squared, now we are able to solve this problem in a linear fashion by drawing a line here. So that is awesome. That's really cool, guys. So this is the kernel trick that is being used by SVM and in a lot of machine learning algorithms. The way to solve the problems which are not linearly fashionable, which are not linearly separable, by introducing those new kind of factors. I hope you like this, guys. Thank you.